Good morning, everyone. I'm Shuang from the University of Michigan. I'm not in their team because I'm only here to help them to present their papers. Uh, this work is done by Ze Yuqiu, joined with De Qiangkong, Zhen Fengzhu, Han Qinglu, and Jian Cheng. Okay, first of all, I'm still going to briefly introduce some background and problems of this contest. The goal of KD Cup this year is to predict the numbers of papers for some institutions in certain conference based on their publication history. There are three phases for the contest, each phase corresponding to some different conference. And Microsoft Academic Graph dataset is provided in this contest, but this team also used the A minor and DBLP dataset, which were publicly available. The measuring metrics of this contest is EG at 20, and the final contest score for a team is a weighted summation of your score in all three phases. Okay, next is their solution to this contest. This is the basic framework of their work. The raw dataset contains the location of the conference, the top institutions, the trend of the conference, and the field of study. Then they try to extract some features from this raw data, and after that, the random forest model and the gradient boosting regression tree were utilized. And the prediction from the two models were then assembled to get their final prediction. The raw data set actually could be interpreted as a heterogeneous undirected graph, where the institutions and the authors and the papers can be used as three different categories of nodes for this graph. They extract different kind of features according to the category of nodes. For the institution nodes, they extract the following features. The first set of features is the probability indication feature, which is focusing on describing the inherent property of an institution by one-hot encoding. The information encoded here are the institution ID, location ID, and the champion indication. And next, they use the weighted page rank algorithm to extract this relation. They built a three-layer heterogeneous graph for one conference, and the graph includes three layers, which are the layer of papers, the layer of nodes, and the layer of authors, and the layer of institution. They also incorporate some time delay factors to model the edge of this graph. And after alternate update of this page rank algorithm, they can get the value. They can get some weight value of the institutions, and they apply that as their features. And then it's the for the nodes which stand for the authors, they have the following feature. For the other feature, they try to extract the features from two aspects, named the activity degree and the continuity degree of an author. The activity degree is actually try to describe the activity of an author in a conference. If an author can publish many papers during a certain time window, then this author is regarded as an active author, and and for the continuity degree, if an author can publish some papers in several consecutive years, then they believe this author will also publish papers for the next year with high probability. They also design some conditions to judge whether a user is active or this author can have a high continuity degree. Okay, for the nodes of paper, they extract the features like the first is the cumulative counts. This feature tries to describe the cumulative publication history of an institution. They translate the counts of the papers for each year to cumulative counts for last 3 years, and last 2 years, and last 1 year. From the right table of this page, you can see that the first column is actually refers to the cumulative counts for the last 3 years, and the second row is corresponding to for corresponding to the publication of the last 2 years, and the third row is corresponding to the publication of the last 1 year. Then it's the ratio of publication. This is a kind of features which shows the public ratio for an institution and a conference. For example, if Microsoft published 23 papers in KDD, and there are also 605 papers for this institution of that year, and 160 papers in the conference of KDD, then the institution ratio is actually 23 over 605. And the conference ratio is actually 23 over 160. That's the ratio of publication feature. This table shows how they try to do some feature selection. In phase 2, they only use the paper feature. And in phase 1, they only use the paper feature. And in phase 2 and phase 3, they use different features for different conferences, not only the paper feature. Okay, considering this is a forecasting problem, for the construction of local training data, they use the data from 2010 to 2012 to extract features as the training feature X, and the number of accepted papers in 2013 as the training predictor Y. And they also did the same thing to construct the validation set, and also the test data set were constructed by a similar way. And they also realized that there's a lack of training samples if they do the construction of their data set for every 3 years. So they tried some ways to increase their training sample, and finally they decided to merge the samples for 3 more years for training from 2009 to 2012. And this diagram shows how they expand their training set. Now, because the prediction difference among a particular category of models with distinct parameters, so therefore, for random forest, they train the models based on different parameter settings in a certain range, and randomly sample a subset of their publication of their prediction. And for GBRT, they also did the same thing. And finally, they do some random samples from the predictions and try to example their prediction by the formula on your right hand side. This formula is actually from another paper. And finally, they got their result. Their team eventually won the first place of phase 2 and got 10th for the overall result. Thanks for your attention. This is the whole work. If you have any questions, feel free to contact the YouTube via his email. Thanks.